In the previous tuition video, we created a rising analog alarm for all NXF4000s in the project. A sensor 1 high alarm triggers at 600 millibar. However, in the current project, boiler 1 sensor is set to millibar, while boiler 2 sensor is in PSI. Obviously, boiler 2 can never reach 600 PSI, so the sensor 1 high alarm will never trigger. This can be solved by the use of custom variables. When the sensor 1 high alarm was created using the wizard, a fixed value of 600 was used for the alarm threshold. We can change this to a user-adjustable value. Within the calculation dialog, add a new calculation tag by clicking the plus icon in the bottom right-hand corner. Give the new calculation tag a name that reflects its purpose. Also, add a proper description. We must choose a data type for the new tag. In this example, we'll use float, since it provides a fine resolution. Next, let's enter engineering data. A maximum of 1020 will account for both boilers' sensor 1 range. Engineering units should reflect the boiler's sensor 1 setting, so enter millibar/PSI. We must select the calculation type to variable. This instructs NXTSD5 to use the tag as storage for a value, which is user adjustable and retained when powered down or rebooted. Finally, change to the expression page. We must enter the calculation tag's expression. This tag won't be providing a result, so it won't need any Python script. However, it will require a default value. Simply add a new line, which contains a value of 600. The results area will instruct if there's an error, but this example has no issues because the default value has been declared correctly. When the calculation tag is accepted, it appears in the calculation dialog alongside our sensor 1 high alarm. Now we must change our sensor 1 high alarm to make use of our custom variable. Open up the Properties and Change page to find the script that triggers the alarm at a fixed value of 600. Click on the line of Python script to edit it. Delete the fixed value of 600, and use the Insert tag feature from the on-screen keyboard to locate the custom variable we just created. Now our sensor 1 high alarm is triggered when sensor 1 rises above our custom set point. Don't forget, because device-based is enabled, every NXF4000 in the project will have this capability. Let's exit to the overview and test the alarms. Boiler 1 is currently at 440 millibar, and boiler 2 is at 16.45 psi. Go to the System menu and select Tools, then Monitor User Variables. This is a special dialog that only shows custom variables, and we can see the sensor 1 high set points we've just created. Both set points are using the default value of 600 that we specified. Let's change the set points so they're relevant for our boilers. Set boiler 1 to trigger at 500 millibar, and boiler 2 to trigger at 20 psi. Don't forget, these values are retained so they're effectively just like any other parameter. Finally, let's test the alarms. Boiler 1 sensor 1 high should trigger 5 seconds after rising above 500 millibar. And boiler 2 sensor 1 high should trigger 5 seconds after rising above 20 psi. Viewing the active alarms reveals both alarms are present. When the sensor values drop below their set points, the alarm conditions subside.